Okay, everyone. We will starting with the kinematics of the particles. For the topic today is still related to the kinematics of the particles, but we will moving to the curvilinear motions. Okay. Before we go that, I add more example, that related to the rectilinear motion also. Actually, you all doing very well for the rectilinear motion in our classes, and but I just adding some review. Let me take a look these problems. Okay, for this problem, we know that the particles move along a horizontal path with a velocity of the function. We have the velocity functions in meter per second, and the time is in seconds. If it is initially located at the origin point O, okay, so we would like to determine the distance travels in 3.5 seconds and particles average velocity and average speed during the time interval. Okay, so the problem is marked that the problem is sorry. Okay, you see the screen now. Okay, the problem is marked that we have the distance. Okay, we would like to determine distance. Distance is the scalar quantity. It's a scalar quantity. It means that it is the total motion, the total distance. The distance is not like the displacement. Displacement is the shortest distance. Okay, but for the distance, it is a scalar quantity. So then we have to be careful when we found this word. Okay, it's maybe not just the integration of the velocity function, and then we substitute the limit of time, and then we for that formula we got just only the displacement. Okay, if we would like to determine the distance, we have to plot the path also. And the particles average velocity is a vector quantity that we have to, if we will determine the average velocity from the displacements. But average speed is a scalar quantity. We have to determine it from the distance. Okay, so these two words we have to be careful. And for this problem, we use just only the fundamental formulas, that is A equal to dV by dt, V equal to ds by dt, and AdS equal to VdV. We use just only this relationship. The solutions of this problem I select this from the text of people. You can review it again. And if you see for the solution, so as I mentioned it before, because we would like to determine the distance. Okay, so we know that we determine this time is equal to the integration of the displacement function that we already have. And after we substitute, we got the displacement function like this. Okay, so if we mention just only the time and we substitute the limitation of the time from 0 to 3.5, okay, we got the solution that we have just 6.125. Okay, but it is not the answer for this time. It is the displacement from 0 to from time equal to 0 to time equal to 3.5. So it's maybe how to plot. If we plot the velocity function with the time, we found out the velocity has a negative value in the range of 0 second to 2 second. What does it mean? It means that the velocity is moving to the left, because we set up to the right is a positive one. Okay, so the velocity is negative. So it means that the motion is moving to the left for 2 seconds. And after that, it changed the direction. The velocity it changed direction to the right instead. So then we may have to determine the position of the particle at any time. That is the critical time. For this case, we found out at the starting point. When time equal to 0, s equal to 0, this is the initial condition. And we have to determine at the end point of when the velocity change the direction. So it means that at the point of velocity is equal to 0. So then when time equal to 2 seconds, we can determine that the position is become minus 4 meter. Okay. So that's why it means that the distance traveled in 3.5 seconds is become, we have the part, total part is become 4 meter from 0 to from point O to time equal to 2 seconds, and then it's come back to the original one. So then it's become 8 meter, right? And then after that, about the 1.5 second is moving to the right of 6.125 meter. So then the total distance is become 14.125 meters. Okay, so this is the first answer. It is the first one. And if we would like to determine the displacement, okay, displacement is used for determining the average velocity. Okay, for displacement, we determine from 0 to 3.5 seconds. So then it is the shortest distance from time that we would like to find. Okay, that from the starting point to the end point, and then we found out the displacement is become 6.125 meter, and then it means that the average velocity, according to the definition, we determine its form delta s equal to delta divided by delta t. So then we have the average velocity of 1.75 meter per second is to the right. Okay, and for the average speed, we have to determine from the distance. Okay, so average speed and average displacement now is not equivalent. Okay, so for this case, we use the total distance, and is equal to 14.125 meter divided by the total time, the total elapsed time, that is equal to 3.5 seconds, and then we got the speed of 4.04 meter per second. That is the complete for this example. Okay, do you have any question? Okay, that's all. That's complete this problem. Okay.